this video, we will take a look for the next subtopic, subspaces, page number 78. Let's say we assume V is the vector space. So remember, in this course, we deal with three types of vector spaces: Rn, polynomial, and matrices. And S here is a subset of V. So we can say that S here is a subspace of V if and only if, okay, so it means that we have two conditions here. First one, there exists vector X and Y in S such that if we add these two vectors, X plus Y is still in S. Okay, the second condition, there exists K. K here is a scalar. Okay, such that if we multiply K with vector X, still in S. Let's try to solve example in page number 78. So determine whether the set W, okay, you are given here set W, is a subspace of matrix 3 by 2. So means that our vector space here is matrix 3 by 2. So we need to show that is it W here is a subspace of matrix 3 by 2. So what we need to do? First one, we need to let two vectors, let's say here A and B, in W. Then, alright, so A here must be vector in W. So we must follow the given vector in W here. So A here, we use A1, B1, 0, C1, D1, 0. Okay, you can use any unknowns, but it more easier if you just follow whatever in W here, you just change this one into A1, B1, 0, C1, D1, 0. Okay, so the next one, you can see here, we have the condition here where A plus B equal to 2D. So means that for vector A here, we must put the condition where A1 plus B1 equal to 2D1. Next, we introduce vector B. So B also must be vector in W. So B here, you can write it as a A2, B2, 0, C2, D2, 0. Okay, same thing here. We also must put the condition for vector B. So now it will be A2 plus B2 equal to 2D2. So the first step is we introduce two vectors. Okay, let's say here I use A and B in W. So remember W here is given in the question. Then after we introduce two vectors in W, so now we show for the first condition where we add two vectors. Then we try to show that it's still in set W. So now we add two vectors A plus B. Okay, this one for the first condition. So we introduce two vectors and then we add these two vectors A plus B. So this one and this one, actually you do the normal addition for the matrices. So you will have here A1 plus A2. Okay, the next one, B1 plus B2. So 0 plus 0, you will get 0. C1 plus C2. D1 plus D2 and 0 here. Alright, so next we come up with the condition. Alright, so what is the condition now? Okay, we refer to the original W. A plus B means the element here plus element here equal to 2 multiplied with element in D here. So the element here is A1 plus A2. So A1 plus A2, okay, plus B. B element for these entries. So this entry is B1 plus B2 equal to 2 multiply with D. So D means that the element here. So the element here is D1 plus D2. Next, what we need to do, we must prove whether the condition here, okay, the condition is now A1 plus A2 plus B1 plus B2 equal or not with 2 multiply with D1 plus D2. So the next step we need to prove for this condition. Alright, so let's say I assume this one as a left hand side and this one right hand side. So we show left hand side first. Okay, so you take the left hand side here. So A1 plus A2 plus B1 plus B2. So now you open the bracket, you will have here A1 plus A2 plus B1 plus B2. Alright, so the next step, we will use the information from the two vectors that we introduced just now. So we have here A1 plus B1. So you have here A1 plus B1. And for this one, you have A2 plus B2. So this one also we have A2 plus B2. So we just rearrange. So we rearrange this equation. So A1 plus B1 plus A2 plus B2. Okay, so now you can substitute A1 plus B1 equal to 2D1. And A2 plus B2 equal to 2D2. Next, I will factorize 2 here outside. So I will have here 2 multiply with D1 plus D2. Okay, so next, you check with the right hand side here. You get the same answer? Yes, if you get the same answer, means that this one equal with right hand side. Since left hand side equal with right hand side, means that the first condition, okay, addition of two vectors A plus B in W. So the first condition is satisfied. Next, we need to prove for the second condition. The second condition is scalar multiplication. So the first one, you must introduce, let's say K here, be any scalar. Okay, then we show for the second condition. Okay, K multiply with A. Alright, so A is the vector that we introduced for the first condition just now. So K multiply with A. So A is A1 B1, 0, C1, D1, 0. So what you will have here? KA1. Okay, we just do the normal scalar multiplication. 0, KC1, KD1, 0. So we get the scalar multiplication of K multiplied with A. So next, okay, we come up with the condition for the scalar multiplication. Same thing, we refer with W here. Okay, the given W in the question. So A plus B. So what is our A now? KA1, K plus B. So what is our B now? KB1 equal to 2 multiplied with D. So our D now KD1. So the condition now KA1 plus KB1 equal to 2KD1. Next, we want to prove is the condition here. Okay, is KA1 plus KB1 equal with 2KD1. Okay, as usual, I will let it this one as a left hand side and this one right hand side. We start from the left hand side. So this one left hand side KA1 plus KB1. So I will factorize K first. Alright, so K here A1 plus B1. So A1 plus B1. Okay, we have the information here. A1 plus B1 equal to 2D1. And then you substitute. Okay, this one with 2D1. And then if we solve it, you will get here 2KD1. Okay, same thing. We compare this answer here with our right hand side. Is it equal? Yes, it's equal. So that means this one equal with right hand side. So we conclude for the second condition first. Since left hand side equal with right hand side, hence the second condition K multiplied with A in W. The last step, we must conclude. Okay, since both conditions are satisfied, means that W now is a subspace of matrix 3 by 2. That's how you show that. Okay, when the question asks you to show W or any set is a subspace of any vector space. As your practice, please solve exercise page number 79 in your textbook. Okay, so same thing, you must determine or you must show W is a subspace of V. So V now is a vector space of 2 by 3. So solution, all the steps required to solve this exercise actually same as I showed it to you just now. Next, let me show it to you how to solve example page number 80. Still about subspace, but now our vector space is polynomial. Okay, polynomial of degree 3 or less than 3. So, we are given W. Okay, you can see here W here is a vector in polynomial of degree 3 or less. Okay, and the condition here A multiplied with B. So A here is the coefficient of X and B here coefficient of X square. So if you multiply these two, you will get here equal to 1. So the question asks you to show that W is a subspace of P3 or not. First, we try to prove for the first condition. To prove for the first condition, we must introduce two vectors, okay, in W first. Okay, so Px, okay, I use now Px. Alright, so remember, Px and Qx in W. So we must follow the given W here. So Ax plus Bx square plus Cx square. So now Px, I will introduce as A1x plus B1x square plus C1x cube. Okay, same thing. Now the condition. A multiply with B. Okay, so A multiply with B. So now is A1 multiply with B1 equal to 1. Next, we introduce Qx. Same thing, Qx also must be in W. So if this one I use A1, so for Qx, I will use A2x plus B2x square plus C2x cube. Same thing, the condition now will be A2 multiply with B2 equal to 1. For the first case is addition. Addition between Px plus Qx. So we do the addition. Px plus Qx. So Px is this one. So A1x plus B1x square plus C1x cube plus Qx. So our Qx is A2x plus B2x square plus C2x cube. So I will open the bracket first. So we will have here A1x plus B1x square plus C1x cube plus A2x plus B2x square plus C2x cube. Next, I will rearrange, okay, based on the same variables. X with x square with x square, x cube with x cube. So you will have here A1x plus A2x plus B1x square plus B2x square plus C1x cube plus C2x cube. Next, I will factorize. Okay, for the first one here, I will factorize x. So here I will have now A1 plus A2x. For this one, I will factorize x square. So I will have here B1 plus B2x square. And for this one, I will factorize x cube. So C1 plus C2x cube. After we finish, add between Px plus Qx. So now we must come out with condition. Okay, so condition, we refer back to the W. So A multiply with B equal to 1. So A here, remember the coefficient of x. So what is our A now? Coefficient of x here is A1 plus A2. And then multiply with B. B here is the coefficient of x square. So our coefficient of x square here is B1 plus B2 and then equal to 1. Next, we want to prove is the condition we come up just now is true or not. Okay, so is A1 plus A2 multiply with B1 plus B2 equal to 1. Same thing, So I will denote this one as the left hand side and this one as right hand side. So we prove start from the left hand side. So left hand side here is A1 plus A2 multiply with B1 plus B2. So we open the bracket first. We do the multiplication first. So you will have here A1 B1 plus A1 B2 plus A2 B1 plus A2 B2. Next, okay, we try to check the information we have about this 4 term here. Okay, so we go through or we go back to the 2 vectors that we introduced at the first place. Okay, so from this one, we have A1 multiplied with B1 equal to 1. So we have here A1 multiplied with B1 equal to 1. How about A1 multiplied with B2? We don't have any information, then you just write it back. So A1 multiplied with B2. Same thing for this one, we don't have any information. So you just write it back. A2 multiplied with B1. Okay, so how about A2 multiplied with B2? So we have here A2 multiplied with B2, we'll get here 1. So we solve here 1 plus 1, 2 plus A1 B2 plus A2 B1. Right, so next you check with right hand side here. So right hand side here equal to 1, but this one you get 2 plus A1 B2 plus A2 B1, means that not equal with right hand side. Since left hand side not equal with right hand side, then we conclude that the first condition, Px plus Qx, not in W. Since the first condition or first case is not satisfied, then you can conclude that W is not a subspace of polynomial of degree 3 or less. Means that you don't have to show, you don't have to prove for the second case or for the second condition. You can directly conclude W is not a subspace of P3. As your practice for vector space in polynomial, so please try the exercise page number 18 on your left hand side here, the box on your left hand side here. Next, I will show it to you how to solve this exercise. Okay, page number 80. Alright, same thing. You need to show W here is a subspace of matrix 2 by 2. So now our vector space is matrix 2 by 2. But the difference is, previous example, we are given the condition, okay, for the vector W. But now, if you can see here, we don't have any condition for the vector W. So how we solve for this kind of question? The first step is the same. We need to show or we need to prove for the first condition or for the first case. Okay, so we introduce 2 vectors in W. So let's say here I use A. So A here, remember in W. So if this one use AB, negative BD. So for A here I will use A1, B1, negative B1, D1. Okay, so next we introduce B. Alright, so A2, B2, negative B2, D2. So if you can see here, we don't have any condition for A and also for B. Why? Because W here also we don't have any specific condition. So we just follow whatever in W. First case, to show W is a subspace of matrix 2 by 2 is addition. So we add A plus B. So A plus B, okay, as I said to you previously, we just do the normal addition for two matrices. So you will have here A1 plus A2 for this element, B1 plus B2 for this one, negative B1 minus B2, and for this one, D1 plus D2. Okay, how we show that A plus B, okay, this one, A plus B here in W without any given specific condition. So we don't have any specific calculation, but we just prove through our investigation. Okay, so now we refer the given vector W here and the vectors that we get when we add A plus B here. Okay, now we check. Alright, so these entries is A. Alright, so we have the entries here is A1 plus A2. Okay, this one is B. So the entries here is B1 plus B2. Okay, so we don't have any problem. Now, so the next entry here is negative multiply with these entries. Entries for B here. So now we check here. Is it satisfied this one? So now we take here negative. Okay, so B. So our B here is B1 plus B2. Right, so we solve for this one. What we'll get here? Negative B1 minus B2. And then you check here. Is it equal? Equals. Means that this one satisfied this one. Okay, next one is D. So this one also our D lah. D1 plus D2. Then we can conclude that A plus B in W. Since first case is satisfied, so we must show for the second case. So for the second case, first we introduce K be any scalar, and then we do the scalar multiplication. K multiply with A equal to, so K, what is our A? A1, B1, negative B1, and this one D1. So same thing, you multiply K with all the element inside the matrix 2 by 2 here. So we will have here K A1, this one K B1, this one negative K B1, this one K D1. Next step, same thing, we want to show is KA, okay, the second case here, in W. Alright, so same thing here, we refer to the vector W here. Alright, so now we have A here, so our A here KA1, okay, B, so our B is KB1, okay, for this one. Alright, so supposedly negative multiply with the entry here, okay, entry B here. So negative, okay, we check for our scalar multiplication. Okay, so negative multiply with the entry here. So negative KB1. So then you open the bracket, you will have negative KB1. And then you check, is it this one and this one equal? Yes, equal. Alright, so means that this one also satisfied the W here. Alright, so the next one D. So this one D, so our D is KD1. So means that now Ka also in W. Lastly, we can conclude that since both conditions are satisfied, means that W is a subspace of matrix 2 by 2. As your practice, I want you to solve all the exercise or all the question, homework 4.3, page number 81. Before we proceed for the next subtopic, spanning set and linear independence.